Greetings. So I'm here to talk about a little bit about quantum computers and a little bit about what we can do and what opportunities are available inside of Web3 for blockchain in the near and the far term. So these are the companies that are currently making quantum computers. There's also labs and government agencies that are adding to this list, but this list is organized by technology, with anything from nitrogen vacancies inside diamonds to photonics. And most of these companies are targeting 2026 or 2027 for 1 million qubits or 10 million qubits. Now, the size of the question you can load is limited by the qubits that are available, but then there's a certain number of operations that need to occur. And this is a very typical timeline from one of those companies. And on the right-hand side, you can see that for 2026, they're targeting 1 million qubits. And that target is still shy of what's necessary to break Bitcoin. This is an estimate from Veritasium, and the hardware improves year after year, which puts more and more possibilities that can be solved. Different problems can be solved. And then as the algorithms improve, it lowers the requirements necessary to actually solve the same problems. This was a forecast that was created in 2022, but the actual performance is much different. Last year, Latensky released an algorithm that described how to use 1152-qubit systems to break Shor's algorithm, discrete log problem, using Shor's algorithm on 256-bit cryptography. Now, it still requires many of these machines instead of just one, but it still brings the hardware requirements far, far lower than expected. That expectation change, the algorithm change, is a very, very different shift in the way that the computers are made and calculated. So instead of having one gigantic machine that we can't build, now we're able to use a bunch of small machines that we can build. And once you have enough of them manufactured, you can then solve Bitcoin. So this is the active volume paper. This was put out in 2022, and he originally described RSA 2048, which is what most SSL certificates are issued in these days. This talks about the performance gains from networking, even if the same number of qubits are used, by simply spreading the problem to a large number of smaller machines, same total number of qubits, it's a 48 times speed increase. And that is a massive, massive, massive shift. This is the paper that was released last year. And they're looking at 3.8 hours for a key solve. That's taking money out of Satoshi's wallet after 3.8 hours of compute time. And this uses a networked model. This is lots of different topologies, different hardware involved. And regardless of what kind of computer is used, you're still looking at massive performance gains, and you're still seeing that this is feasible within the next 1 to 2 years. On the left, we're talking superconductors, and on the right, we're talking trapped ion. Superconductors include IBM, trapped ion includes Oxford Ionics, and in the middle is PsiQuantum's photonic systems. And you'll notice that there's different performance that's included here. He actually included like 20 kilometers of fiber optic cable in some of his calculations, just to show the inverse relationship on speed and memory. So there's actually, you're looking at 8.3 seconds per private key removed out of the public key. So the way that this works is you're actually taking the public key, or a transaction from that exposes a public key, and you're converting that into the private key. This is the hardware diagrams for the photonic systems that are currently in mass production. And PsiQuantum has been working with Global Foundries since May, and they've been involved in production of these machines. The only thing left to do is just make enough of them, and Bitcoin is solved. In terms of timeline, we don't really know when the cryptography will be broken. The earliest could be 2025. China is ahead of the United States and the West in terms of raw quantum computing. The West is ahead in terms of error correction. We simply do not know. However, by looking at the production estimates and looking at the satellite photos of the various production facilities and talking to people in the industry and sharing these papers with a number of quantum physicists and experts in the field, 2026 to 2027 is a likely solved date, at which point the value would quickly approach zero for Web3. I recommend Latinsky's YouTube video at QIP where he explains his algorithm to a bunch of cryptographers. And he doesn't explain it to quantum physicists, he explains it to people who don't know quantum algorithms, and he talks about how the costs are estimated and calculated. People talk about quantum AI and all of the benefits that they expect to see from quantum computing, and this slide came from our advisor who works at Polygroup, Pierre-Luc. The elliptical curve discrete log problem is basically the next target. There's a large number of operations and an increasing number of qubits. Based off of the number of qubits, you can actually perform different tasks, and based on the number of operations affects the runtime. Now you can increase the number of qubits for a problem, and that makes the solve time much, much lower. Now, I mentioned this briefly, what they're looking at is the public key, and they can take a public key of an elliptical curve and convert that into the private key. So if you've done a transaction and you've interacted with a smart contract, that has exposed your public key to the blockchain. And if you're talking about Monero and Zcash, it's not recorded, but it's still exposed. In terms of Ethereum and Solana, that key has been recorded and it's a permanent part of the ledger. Looking at that list of public keys, they can then create the list of private keys that were used to sign those messages and validate those transactions. This is not interactive. You can have your wallet on a piece of hardware that's turned off and disconnected or buried in your backyard. And if you've done a transaction before, this can take the money that remains in the wallet and spend it. This can look at smart contracts administrators and upgrade the libraries if that was part of the contract. They can look at the validators and they can unstake all of the coins and send them to themselves. This is essentially the end of Web3. Now, if people try to sell and cash out, the problem is that there's $1.7 trillion locked in various blockchain projects, but there's only 150 billion in USDC and USDT. You can't actually withdraw that. They won't deposit it into your bank account. So this is far worse than even this number would indicate. The issue becomes that anybody who's offering money in your bank or money in your hand in exchange for crypto will run out of cash. They won't have enough cash. And that risk begins as soon as the public awareness increases. And when people start to understand this is a problem, they're going to start withdrawing to cash. There's not enough cash. So what we're doing is we're building an entirely new cryptographic basis for blockchain. And this is based off of the NIST post-quantum cryptography. Instead of having a 32-bit private key and a 67-bit public key, we're using a 64-bit private key and a 3 kilobyte public key. And this is a part of the crystals dilithium standard, and it's a little bit slower, but it's a lot safer. And this quantum safety means that a quantum computer can't attack that math problem and spend the money out of that private wallet. Now, there's other things that quantum computers can do, but these algorithms were chosen because this is not something that they can do well. Part of the opportunity here is that we're going to be able to provide a chain where there isn't a #1 NFT platform. There isn't a #1 DEX. Whoever comes to our chain first and builds will have more and more users as they migrate onto a new chain and a new economy. So this is a fundamental opportunity for people who are early adopters. Now there's going to be other quantum opportunities that I'll talk about, but just simply migrating to the new chain, compiling and deploying the project is going to be an opportunity. And we're going to have a Solana-based virtual machine available in a few months as well, and then we're going to interact with possibly Cosmos and possibly Avalanche. So Signal, Apple, and Google have already migrated to post-quantum cryptography. We're going to need to do the same thing for the entire Web3 ecosystem. We're migrating Hard Hat, we're migrating the Web3.js libraries, and we're migrating MetaMask to all use quantum-safe cryptography. We're removing the existing cryptography to break compatibility with the old networks. We need a clean network. We need a clean environment, not one that will be half destroyed or a third destroyed. By having a clean network, we have clean opportunities. Now, some of these are my competition. I recommend that you use them. I want to save Web3, not just build one project on top of Web3. We need to have a massive migration of assets and resources off of unsafe elliptic curves and start using safe cryptography. So I recommend anybody on this list. However, there are companies not on this list that I would not recommend. I'm not going to call them out, but there's a lot of people who are not quantum safe, and they claim to be. Thank you very much for your time. I can answer a question or two, and I can also talk about quantum opportunities if you guys like. Preference? So quantum computers will have their own version of cryptography, which means that we can have our own version of a quantum blockchain in several years. Quantum computers will need to interact with silicon computers, and one of the best ways to do that would be a silicon to quantum bridge. People have asked me what's the best thing that quantum computers can do, and I say, well, we can get a quantum theory of gravity based off the experiments that were already done creating quantum wormholes using two unconnected quantum computers. They're able to communicate directly through entanglement in violation of the speed of light. So we're able to have direct communication anywhere in the universe using quantum computers. And if we can get a good version of quantum gravity, then we can build things like anti-gravity. So there's a lot of opportunity coming from quantum computers. And thank you for your time. I'll be around.